Hello everyone, welcome back to the session 2 of chapter 1, that is field effect transistor. In the session 1 we discussed about what is FET, what are the classifications of FET and what are the different terminals and constructions of FET. FET is nothing but the field effect transistor. It is broadly classified into two types. One is JFET and MOSFET. JFET is again classified into N-channel JFET and P-channel JFET. Coming to the MOSFET, MOSFET is broadly classified into enhancement type and the depletion type, which is again classified into N-channel and P-channel. Coming to the construction of JFET, like if we consider the N-channel JFET, it will be having a N bar in which the sides will be a P type. So construction will be like this. So sides, this is an N bar. On the sides will be having two P type semiconductor layers. This is the N bar. So these P type semiconductors will be internally connected to form a common terminal, what is called as the gate, and this N type will be given the ohmic contacts, and this terminal will be called as the source and this will be called as the drain. Coming to the P channel, the bar will be the P type and the sides it will be the N type. Again these two N type semiconductors will be connected internally to form a common terminal, what is called as the gate, and here will be having the drain and here will be having the source. Coming to the symbolic representation of this N channel and the P channel JFET. So this is the N channel where this is the gate, drain and the source. Coming to the P channel, this is the gate, drain and the source. The arrow mark will be pointing towards the vertical line in the N channel and the arrow mark will be pointing away from the vertical line in the P channel. So this is all about the construction and the symbol of the JFET. And what are these terminals functioning? Source is the terminal which gives the charge carriers, drain is a terminal which collects the charge carriers, and gate is the terminal which controls the flow of charge carriers. So this is all about the construction as well as the terminals. Now in today's session we will be starting with the formation of depletion region in JFET. Along with that we will also see the working of N-channel JFET. And one more thing, this P type semiconductor is heavily doped compared to this N-type semiconductors in the N-channel. So like coming back to this formation of depletion region, at the end of this session I will be telling you some of the important points which will be helpful for you in the exams. So please watch the video till the end. So let's get into the topic. So here let me consider an N-channel JFET. Here I will be having two P-type layers, P-type semiconductors, which are connected internally to form a terminal, what is called as a gate, and there will be two ohmic contacts. This will be called as the drain and this will be called as the source. In this particular diagram, this is the N channel. So this is the channel through which the charge carriers will be flowing from the source to drain. Here the N channel or the N type semiconductor will be having electrons as the majority charge carriers. So the electrons will be flowing from the source to the drain. So here in this particular diagram we will be having two PN junctions. Where are those PN junctions? This is a P layer and this is an N channel. In between these two we are having one junction. So this is one junction, and here again N channel and P type semiconductor. So in between them again there is a junction. So totally I will be having two PN junctions. In order to understand this formation of depletion region, we have to reverse bias this PN junctions. So in order to reverse bias the PN junction, P-type semiconductor must be connected to the negative terminal of the battery, and the N-type, that is the N-type is connected to the source terminal. So the source must be connected to the positive terminal of the battery in order to connect this PN junction in the reverse biasing condition. So what is this biasing? Biasing is nothing but applying external voltage to the junction. What happens when the external source or the external voltage is applied to the PN junction? There will be the variation in the depletion region. The depletion region will either starts increasing or decreasing depending upon what kind of biasing I am applying. So what is this depletion region first of all? Depletion region is a region where neither of the charge carriers are present. Neither the holes nor the electrons are present in that particular region. That region is free from the free charge carriers. That region is depleted from the charge carriers. In the first year already we have studied about this depletion region. So the width of the depletion region will completely depend upon the biasing what we are applying, whether I have connected the forward bias or the reverse bias. Forward bias in the sense, positive terminal of the battery must be connected to the p-type semiconductor, negative terminal of the battery must be connected to n-type semiconductor. Reverse bias anta helidre, positive terminal of the battery must be connected to the n-type and the negative terminal of the battery must be connected to p-type. So here in this particular diagram, I have connected the PN junctions in the reverse biasing condition. Here, as soon as I start increasing this voltage or as soon as I start applying this reverse voltage, there will be a formation of depletion region across these junction. There will be a formation of depletion region like this across the junction. The width of the depletion region will be same if the level of doping is same for both n-type and p-type semiconductors. If the doping doping is nothing but adding impurity atoms. If the number of impurity atoms added is same for both n-type and p-type, then the depletion region will extend evenly on both p side and the n side. But here in this JFET, P layers or the p-type semiconductors are heavily doped compared to n-type semiconductor. So what is this, what happens to the depletion region? Depletion regionally, the width will completely depends not only on the external voltage what I am applying, it also depends upon the doping levels what it is done. Here, since p-type is heavily doped compared to the n-type of semiconductor, the depletion region will extend more towards the n-type compared to p-type. So now let us see what happens if I start increasing the reverse biasing voltage which is applied between gate to source terminal. As and when the reverse bias voltage is increasing, the electrons from the n-type starts diffusing from n-type to p-type crossing the junction, and the holes start diffusing from p-type to n-type. Electrons n-type in the p-type diffuse ಆಗ್ತಾ ಹೋಗ್ತಿದ್ದಂಗೆ there will be formation of positive ions on the n side and negative ions on the p side. So what is this positive ions? An atom which has lost an electron itself will be called as positive ion. So those electrons have crossed the junction and reached the atom which are present on the p side. So the atom which has gained an electron will be represented by the negative term, negative polarity. So these are negative ions. So this becomes a region what is called as a depletion region. So this itself is called as a depletion region. So depletion region in the sense a region where none of the charge carriers, none of the free charge carriers will be present. Free electrons iralla, hagene holes kuda iralla. As and when I start increasing this reverse biasing condition, the width of the depletion region ಏನಾಗ್ತಾ ಹೋಗುತ್ತೆ, it starts increasing. So increase ಆಗ್ತಾನೆ ಹೋಗುತ್ತೆ. So if I decrease this reverse biasing condition, the width of the depletion region ಏನಾಗ್ತಾ ಹೋಗುತ್ತೆ, decrease ಆಗ್ತಾ ಹೋಗುತ್ತೆ. ಈ reverse biasing voltage ನ ನಾನು increase ಮಾಡ್ತಾ ಹೋದಷ್ಟು the width of the depletion region will start increasing. Thereby we can say that the width of the depletion region not only depends upon the voltage, it also depends upon the doping levels of this semiconductors. Clear? Like this, by applying the reverse biasing condition, there will be a formation of depletion region across the two junctions. Here I have taken an n-channel JFET. So in the n-channel JFET, we will be having an N bar on the sides of which we will be having two p-type semiconductors, and these two p-type semiconductors will be internally connected to give a terminal what is called as a gate, and this N channel will have a ohmic contact to give two terminals. One is called as the source, the other one is called as the drain. So this PN junctions, there will be formation of two PN junctions in this N channel JFET. So this PN junctions has to be reverse bias in order to form a depletion region. So how to apply that reverse biasing condition? Between the gate and the source, we are going to connect an external voltage source that will be reverse biasing the two PN junctions, which leads to the formation of depletion region. Next we are going to see the working of N channel JFET. Now let us see the working of N channel JFET. So let us draw the diagram first. This is an N channel where it will be having two p-type semiconductors, and that p-type semiconductors will be internally connected to form a terminal what is called as a gate, and this N channel will be having ohmic contacts to give the terminals what is called as the drain, and the other one source. So in order to understand this working of N channel JFET, we have to reverse bias this PN junction. So what we are going to do, we are going to connect a voltage source between the gate and the source terminals of the JFET, such that the negative terminal of the battery will be connected, or the negative terminal of the source will be connected to the p-type semiconductor, and the positive terminal of the source will be connected to the source, that is to the N-type semiconductor. Apart from this, we should also connect a voltage source between the drain and the source, such that the negative terminal of the battery is connected to the source and the positive terminal of the battery is connected to drain. Let us call this as VDD and let us call this as VGG. So VGG is nothing but a voltage source that is connected between the gate and the source. VDD is nothing but a voltage source which is connected between the drain and the source terminal. Now let us try to understand what happens. So here, as VGG 0 irbekare, VGG in the sense the gate to source voltage 0 irbekare, the width of the channel, not the depletion region, I am talking about the channel, the width of the channel will be very large. So there will be enough space for the charge carriers to flow from the source to drain. There will be more space which is available for the charge carriers, that is N channel, which is the majority charge carriers, electrons. Electrons will be flowing from source to drain. As electrons are flowing from source to drain, there will be a formation of current, or there will be a flow of current from the drain to source. Let us call that current as ID. Since VGG is 0 right now, nanina VGG na apply madilla. Since VGG is equal to 0, the channel space available for the charge carriers is maximum. So the current flowing is also maximum, and that maximum current will be denoted by IDSS, which is called as drain to source saturation current. The maximum current which is flowing from the drain to source when the gate to source voltage is 0. Adana now IDSS anta karthivi. As and when I keep on increasing the reverse biasing voltage between the gate to source voltage, there is a formation of depletion region across the PN junctions. Why the current is flowing from drain to source over here? Since VDD source na ನಾವು ಸರಿಯಾಗಿ ನೋಡಿದ್ರೆ, the negative terminal of the battery is connected to the source and positive terminal of the battery is connected to drain. Here in the N channel, majority charge carriers are electrons which are again negatively charged. So this negative terminal of the battery will make the electrons which are present here in this region near the source terminal to push from source to drain. But according to the conventional current flow, the conventional current flows in the opposite direction to that of the electron flow. Since electrons are flowing from source to drain, current hege flow aagtade from drain to source. I hope you are clear with this. Now coming back to this point, as and when I keep on increasing this reverse biasing voltage, there will be a formation of depletion region, and the width of the depletion region will also depend upon this. as I keep on increasing this VGG, that is gate to source voltage ನಾನು increase ಮಾಡ್ತಾ ಹೋದಷ್ಟು the width of the depletion region ಏನಾಗುತ್ತೆ increase ಆಗ್ತಾನೆ ಹೋಗುತ್ತೆ. So there comes a point when the depletion region of the two PN junctions will be touching with each other. These are the two PN junctions. There comes a point when two PN junctions will be touching with each other. So in this particular case, there will be no space for the charge carriers to flow from the source to drain. This is the gate terminal, this is the source, and this is the drain. So when the depletion region are touching each other, there will be no space available for the charge carriers, that is for the electrons to flow from the source to drain. So the current also cannot flow from drain to source. At this point, ID will be equal to 0. Simple like ID antane kelena, ID is nothing but the current which is flowing from drain to source. So the current will be equal to 0. So this condition is called as the pinch off condition, or the voltage at which the current will be equal to 0. The voltage at which the drain current is equal to 0. Our voltage we are going to call it as the pinch off voltage, which will be represented by VP. So what is this VP? The pinch off voltage is nothing but the voltage at which the drain current will be equal to 0. So this is all about the working of N channel JFET. Coming to the working of P channel JFET, it is similar to the working of N channel JFET itself. The only exception is this two terminals, these two terminals has to be connected in the reverse direction. Along with that, the charge carriers in N channel is electrons, whereas in P channel is holes. That is, holes will be flowing from one terminal to the other terminal. I hope you are very much clear about this working of N channel JFET. So working of N channel JFET ನಲ್ಲಿ main ಆಗಿ ಏನು ಕಾನ್ಸಂಟ್ರೇಟ್ ಮಾಡಬೇಕು, we have to connect this PN junction in the reverse biasing condition. Reverse biasing condition ನಾನು increase ಮಾಡ್ತಾ ಹೋಗ್ತಿದ್ದೆ, reverse biasing voltage ನಾನು increase ಮಾಡ್ತಾ ಹೋಗ್ತಿದ್ದಂಗೆ there will be a formation of depletion region, and that depletion region will depend entirely upon the reverse biasing voltage. As and when I keep on increasing the reverse biasing voltage, the width of the depletion region starts increasing, which in turn reduces the space available in the channel for the charge carriers to flow from one terminal to other terminal. So there comes a point when the two depletion region will be touching with each other. At that point, no charge carriers can flow from the source to drain, which in turn reduces the current completely. That is, ID drain current na complete agi zero ಮಾಡುತ್ತೆ, and that voltage will be called as the pinch off voltage, which will be represented by VP. Today we saw the formation of depletion region in JFET, along with that the working of N channel JFET. In the beginning of this session, I told you that I'll be telling you some of the important points that will be helpful for you in the exam. I am going to tell you some of the important questions what can be asked in these particular topics, and how you have to write the answers for those particular questions. So let me see that. Describe briefly the construction of N channel JFET. So this is asked for 2 marks in 2015. Construction anta bandaga try to write this. That is, it will be having N bar. On the sides will be having two p-type layers, or the p-type semiconductors, which will be interconnected, which will be internally connected to give a terminal what is called as a gate, and the N channel will be having two ohmic contacts to give two separate terminals. One will be called as the source, the other one will be called as a drain. Ishtuna bardre saku with a neat diagram. Ashtuna bardre you are going to get 2 complete marks. After that, write the function of source in JFET. This is for 1 marks. The function of source is nothing but it gives or supplies the charge carriers, which helps in current conduction. Ade thara, what is the function of drain anta helidre? It collects the charge carriers. What is the function of gate anta kelidre? It helps in, or it controls the flow of charge carriers anta helbodu. Okay na? Write any two differences between FET and BJT. In the very first session itself, I told you the difference between FET and BJT. FET is a unipolar device, whereas BJT is a bipolar device. Unipolar anta helidre unipolar in the sense only the majority charge carriers will be responsible for the current conduction. N channel consider madidre electrons are responsible, P channel consider madidre holes are responsible. Coming to this BJT, it is a bipolar device anta helidre both electrons as well as holes are responsible for the current conduction anta helbodu. Apart from that, this FET is a voltage control device, whereas BJT is a current control device. ಈ ತರ ಎರಡು difference ನ ಹೇಳಿದ್ರೆ ಸಾಕು, you are going to get 2 complete marks for that. Draw the schematic symbol of N channel JFET. Bari symbol matra baribeku. You have to write the arrow mark facing towards the vertical line. That itself is the symbol of N channel JFET. Ade P channel anta kelidre the arrow mark will be pointing away from the vertical line, where vertical line will be considered as the channel. So these are some of the important questions what is frequently asked for these topics what we have already covered. So let's end this session at this point. In the next session I will be dealing with the characteristics of N channel JFET and some of the important JFET parameters which is most frequently asked in the examination. I will be coming soon with the next video. Until then, take care. Bye bye.